Alright, so question 3 of the 2010 Methods Exam 1 paper. Let's have a look. So it says, let f, a function of reals positive, map to R, where f of x equals 1 on x squared. So the reals positive plays a bit of an important role in this question. So the 1 on x squared graph, if I just graph that in red, should look something like this without all the stupid wobbles I've got in there. So that's our y-axis, that's our x, and we've got this sort of absolute value kind of thing of what we could say was our hyperbola, but it's our truncus graph, so it's slightly more sharp in some areas. You get the general idea. So now what we want to do is we want to find g of x, which is defined as f of x, composite function of f with itself. So all we need to do is take f, so 1 on x squared, and wherever there was an x, we're putting it inside itself. So that's g of x right there. So let's clean this up a little bit. Let's deal with the bottom bit first. So 1 on x squared is just going to be 1 on x to the 4. And now we could write this as 1 divided by 1 divided by 1 on x to the 4, which is the same as 1 on 1 times the flipped version of what's down here. Alright, so the flipped version would be x on 4 divided by 1. And that is just equal to x to the power 4. So therefore, g of x, which equals the composition of f with itself, is just x to the power 4. Alright, so next up, we're still dealing with this same function. And before we just found that g of x equals x to the power 4. So now we want to find the inverse, g to the negative 1 of 16. So how do we go about finding the inverse of a function? Well, to find the inverse, swap x and y if we were to say this is the same as y equals x to the power 4. So if we swap x and y, we'll pretty quickly find that we've got x equals y to the power 4. And now our step 2, so if that was step 1, this is step 2, we solve for y again. So if we go through and solve this for y, we should just get the 4th root of x equals y. So we can write that as being g inverse of x equals the 4th root of x. Alright, but we're not quite there yet. We need to find g inverse of 16. So wherever there's an x, we're just going to sub in 16. And this essentially reads, don't be too confused by it, this reads what multiplies by itself 4 times to give 16. That's the question we've got to ask ourselves in this. Of course, our calculator would just throw us out an answer and that'd be great. By looking at it, and because I know the answer, which is terrific, I can tell you that g inverse of 16 equals 2. Technically it's plus or minus 2. I removed the minus 2 because that's what our domain says. So let me make that explicit. So we only take, oops, that's a really bad take. We only take 2 because we've got reals positive. So therefore we exclude -2 as a solution. So it's just this guy here. Now why is it 2? Because 2 times 2 times 2 times 2, what multiplies by itself 4 times to give 16? Well, it's 2. The same as if we had negative 2 times negative 2 times negative 2 times negative 2, that also equals 16. So there's no sure way of just getting those answers, or not that I really know of. You've just got to look at them and think logically about what it might be. So the same as, you know, what's the cube root of 64? Well, let's have a think. 8's the square root. So that's getting warm. Let's just try something. So 2 won't work, because 2 times 2 times 2 is only 8. 3 is not going to work, because 3 times 3 is 9 times 3 is 27. But 4 times 4 is 16. And 16 times 4, well, that's 64. So technically the cube root of 64 is 4. So just have a go at practicing a few of them. That's the only advice I can give you. But at any rate, our answer for G inverse of 16 equals 2.